Good morning, good afternoon, good evening to everyone. Not sure where around the world you might be signing into this webinar or conference itself, so I just thought I'd start with that. I've been kindly invited to speak on the topic of robotics across what it means for life, medical and biological sciences, both from an on-Earth perspective and an in-space perspective. I think the easiest thing to say at this point is the way that we view robotics today is fundamentally going to change what we look at in the future. I guess as a brief introduction to myself, so I work at KPMG as an associate director within our space client service team, but also within technology advisory, which I guess is my main area. My specialization is pretty much towards technology, strategy, and performance, but specific to space technology and robotics and autonomous systems, which is where my background comes into play. I won't go through the rest of it. You can see that on screen. But I guess I put this quote in the corner because that's something that I look at, and that's really, I guess, my focus towards robotics and why I want to continue doing everything with it. Because fundamentally what we're trying to use robotics for on Earth is going to change the way we look at space and the opportunities that come off the back of that. And Elon Musk is actually one of the, I guess, role models that I look up to in terms of what's happening out there. So I've put that on there. And I'm pretty sure some of you will resonate with that as well, given the audience at this session. I guess to kick things off, the definition of robotics actually has a multitude of meanings, but I've chosen to show here the IEEE meaning of that, or the engineering meaning of that. So a robot is an autonomous machine capable of sensing its environment, carrying out computations to make decisions and performing actions in the real world. That's where we're aiming towards. That's the aspirational part, but there's a long way to go there. So realistically, as it is today, a robot is a machine capable of carrying out computations and performing actions in the real world. The autonomy side of things is where we're still developing. But having said that, different industries regard autonomy as different things, and we'll go through some of those applications as we go through this. But fundamentally, the goal that we're trying to achieve from a robotic sense is emulating what the human does, because a robot that does something what we want to do is kind of that, I guess, the North Star, or the gold star that we're looking for. But firstly, it's important to understand what robotics are currently being used for and what the use cases are at the moment from an on-Earth perspective. And so I'll start with the mining context. Robotics and autonomous systems are used to increase the productivity and the safety of operations. So whether it be, for example, BHP or Rio Tinto, these are some mining organizations that already are using remotely operated and or autonomous vehicles for their mining operations. And that's because the environment in which they operate is quite dangerous. And if you look at all the unfortunate incidents that have happened over the last 10, 20, 30 years, having an autonomous capability is a great way to remove that risk. It's basically about risk reduction and safety maximization. And robotics is one of the key front line runners in terms of what happens here. Another example, which you may not think of as a robotic application, is to solve the world's food challenges. So from an agriculture perspective, having a human walk up and down a field and I guess do what they need to do to pick up crops, mow, to water is arduous. And so if you think about a robot going back and forth in the middle of the night, whatever you want to do in terms of timing, you basically take that extra strain off of a human, and because you've got a robot doing that to, I guess, largely the same level of quality. But having multiple working together is even stronger than one person doing that. So robotics is being used from an agriculture perspective, especially with swarms. Don't need to say this, but I guess Tesla, Toyota, and Nissan, robotics have been used in the car industry for a very long time. I guess a part of that is still manual in nature because of quality control and making sure that the cars reach the standards that they need to be for it to be drivable on the road. But Tesla's a great example. Their painting of the cars itself are fully automated these days, and they've got special paint that go onto it. Another really good example is Porsche over in Germany. So they've got a very aging population, and one of the things that they're, I guess, struggling with is if automation comes into the Porsche factories, people lose their jobs. That doesn't help when you've got an aging population. It actually causes a bit of economic strain. So the way they've gone about it is these robots actually augmenting it. So instead of having someone that's aged trying to bend over to put a seat into the car, the robot flips the car comes to you, so you stay still. That's just a great example of a way that robotics is not replacing the human, it's actually augmenting it. But factory line production is one example. Customer service. So we've gone through, I guess, COVID and the need to have social distancing. So I guess it's not really the nicest of situations if you got someone coming up to you and coughing, but I mean, a robot's slightly different use case, but having a robot come up to you for you to ask, basically like a kiosk on wheels, is another example of robotics and where it's being used. This example specifically was from Munich Airport. And the last of which is still a developing area, is to clean up space. So we're using AI and machine learning and different kind of imaging techniques to look at what LEO and I guess MEO and GEO will look like in the future from a space debris perspective. And now we've got the likes of Astroscale using robotic platforms to really clean it up and catch that. And that's a robotic function. End of the day, you're not going to have someone in a satellite flying around Earth trying to pick up the rubbish. You're going to have that automated through robotic means. And I think everyone knows who this is. Perseverance rover is probably one that I would regard as the most inventive, innovative, and breakthrough robotics device that we've had on this planet, or technically not on this planet, on Mars. So I guess you have to talk about Perseverance to really draw the gap between space robotics and what that means for everyone going forward. And I mean, as you know, Perseverance is just one of many robots on the planet. And I'm not sure if you've heard the quote, but Mars is currently inhabited by robots, not humans, but robots. Something obviously we need to change going forward, but it's exciting. But specifically for this context, for this conference, is for life, medical, and biological sciences. The example that you're seeing at the moment is using, I guess, AI and not so much fully robotic, but I guess manual manipulation of machines to really look at, I guess, your eyes, look at the disease elements that may exist, such as glaucoma or macular degeneration. And I guess the power that comes off the back of this is, yes, you've got a human that can identify what looks good, what looks bad. But when you've got thousands and thousands of data points from across the world, you get an insight like no other. And so using, I guess, the AI and the data and the robotic means to actually assess the ability to, I guess, save someone way before it even becomes a problem is something that's being unlocked every single day. But the exciting thing is we are still learning how to do things through space.
The International Space Station is probably the most fantastic vehicle ever built.
It's a one-of-a-kind laboratory orbiting about 250 miles above the Earth.
And we perform experiments on the International Space Station.
We can do science, we can do experiments, we can learn how to do things out of this world.
And the result will help benefit the people on the ground.
So not only that, but we're also seeing benefits of how we actually assembled the space station.
So the International Space Station in its design was essentially designed like a Lego toy. Lots of big pieces that need to be put together. Some of these pieces are going to be about the size of a city bus.
We needed a way of manipulating or moving these big pieces and very precisely putting them together.
Canada worked with its contractor, which was MDA, and with that company came up with a design that was going to meet the needs of the International Space Station.
The solution to that was using a fairly large robotic arm. And that system ended up being Canadarm2. It could move around the space station, grab payloads, move them to where they needed to be so that the space station could be assembled.
You couldn't have built a vehicle like the International Space Station without a robotic system like this.
And that was when we started talking to Synaptive Medical.
Knowing that MDA has done this before in space, we thought it would be very easy for them to bring that experience and that technology into the neurosurgical area and help us with our medical robotics. We worked with MDA to create Drive. Drive is a robot mounted onto a base that holds a surgical camera that can be automatically positioned to any surgical instrument that's tracked by our system.
What this arm does, it follows you and it tracks you, so it speeds up efficiency.
Ultimately, using the Drive system allows the surgeon to have shorter surgical times, which means shorter recovery times for the patient. and ultimately that's better for the hospital and the patient.
But what the robot does for us is that it allows us to do it safer. You can do it better with less harm to the patient.
The software that runs on the drive system is directly derived from the software that runs the Canadarm2 on the International Space Station.
Those robotics work with and alongside an astronaut to enhance what they do. So that connection is a very direct and real one.
Right now, it's probably the most used system that we could say is derived from the things we did on the space station, and we're pretty proud of that.
And I've seen the arm before, we've seen it on the space station, but I never put the two and two together that I'd have the same arm in the OR at some time now.
I think everybody has this dream of how robotics are going to become more and more a part of everyday life. The things that we do with robotics on the space station is basically pushing those dreams forward. And we evolve the system, we gain the knowledge, we gain the experience, the expertise. So this is kind of the unexpected benefits that we get out of doing a program like the International Space Station.
So as you can see, just from that video alone, there are a number of benefits that come off the back of the usage of robotics, specifically the automated part of things, but also robotics as a platform to really ingest a whole bunch of different data points, and obviously the intelligent algorithms to come up with the output. There's a lot of benefits, and a lot of the benefits can be tailored to specific areas and sectors that you work within. But if I guess dial it down to what we're talking about today, you get benefits such as less surgeon fatigue. You've actually got the robot doing a lot of the heavy lifting or the consistency, because holding your arm straight for 5 minutes actually hurts over time. That leads to less human error. And effectively, using something more automated and stable actually helps you with this efficiency and your productivity at the end of the day. One of the items I mentioned before was social distancing. Not something that I guess robotics would have put their mindset to originally, but I guess COVID's been a great example of the fact that it is usable in those instances. If you look at firefighting robots at the moment, they walk, or rather drive, into those kind of dangerous situations. So it's distancing, but from a different perspective. Agility and flexibility. Try to bend your arm backwards. It's not going to work. A robot can do that though. So it opens up, I guess, more avenues to be flexible, but also agile, quickly doing stuff differently. Precision and accuracy is probably one of the most, I guess, beneficial benefits, if I can say that, for the usage of robotics. Again, try to hold your hand for about 5 minutes in a certain position. Chances are it will become to shake a bit. It's really hard to hold it still. A robotic, arm using different actuators and motors is actually very easy to keep it stable. And so when it comes to incisions and things like that, it can be precise. I guess data-driven diagnostics. So I mentioned the fact that you can use, eye scans or robotic equipment to do those eye scans, but it's driven off the back of actual data and different data points from all sorts of, countries and ages and things like that. Consistency and quality control. So if you're going to, using a generic example, if you're going to cut a cake at a specific area, as you get another cake, you want to cut at that same point. And so you're effectively just going to go up and down, cutting at that same point every single time. Whereas you try to do that manually, there's a risk that you might have it like a centimeter to the left, a centimeter to the right, and things like that. I mentioned smaller incisions before because you're going straight to the point. And that means less risk of infection. And ultimately, I guess one of the biggest benefits is patient safety. You're doing everything that needs to be done in the most precise and agile and flexible manner without causing the patient, any kind of harm. And so less surgeon fatigue and patient safety, and you're starting to, work towards the future. But they're already in use. So what I'm saying here at the moment in terms of, the benefits and use cases and what you saw with the Canadarm, things have been happening for a multitude of years. And I guess that's both the cool part, but also the, interesting part. I guess it's safe to say that robotics isn't fully mature at the moment, and there's a long way that we can go. But having said that, we have come a very long way. And I guess the Canada example is a really good one. But a few of these examples on screen, so automated drug delivery, literally, I'm not sure how many people have seen Big Bang, but literally having a small car drive left and right, doing different things. Human robotic surgeon interaction, so literally a robot arm or some kind of, I guess, robotic device working with the human during surgery itself. Automated eye disease detection, precise incisioning, but also the stability control. You've got fully robotic surgeons. I'm not sure I've ever seen that in a completely zero human environment yet. And that's most likely because of a couple of complications, which I'll mention in a moment. But then you've also got things like exoskeletons. So, for example, everyone's spoken about this perceived super soldier program. Just imagine a human wearing this exoskeleton. I might be only able to pick up 20 kilos today, but with a skeleton, an exoskeleton specifically, it might let me pick up 40 kilos. So just imagine a car crash environment, a person stuck underneath that car. A human's not going to be able to lift that by themselves. Imagine if you had that exoskeleton on you and that gave you that extra power to really, I guess, lift it up. These are the kind of applications that currently exist at the moment and people are working towards.
Hi, I'm Atlas, a robot in the making, developed by Darsh. I have been built for the purposes of demonstrating human-robot interaction. You may ask, what is human-robot interaction? Well, it is a new paradigm where humans and robots can, as you guessed, interact. Humans can work with robots, as equals, to conquer a common objective or challenge. This, what I have just explained, is the definition of human-robot interaction.
And that concept, human-robotic interaction, it's not new, it's not old, it's somewhere in that twilight, I guess, period. We, as a human race, I guess, sometimes think about robotics as replacing a human, not so much augmenting. But if you've got the ability to work alongside a robot, I mean, I'll put it this way, our brains can't have every single data point on this planet. It's just too difficult. But having that stored on your hard drive is possible, right? So imagine the robot having all the data points, all the, I guess, intelligence and all the diagnostic procedures that you would need. But then you obviously have soft touch, you've got the soft skills. You could work alongside with that robot. And basically what I showed you before is one that I'm still working on to help me, put simply, remember how and when to take out the yellow color recycling bin, because I forget. But there are some risks because robotics as a whole is still maturing. And there's a couple of these risks or weaknesses that I'll quickly go through. So they're not cheap, they're quite expensive. So you do need, I guess, specially trained surgeons, a lot of capital, because you are working with highly specialized equipment. And that's at the moment. That might change over time as robotics becomes cheaper and more accessible, but there's that trade-off point at the moment. Lack of soft touch. So you can touch someone softly because you know where the pressure points are and how to actually, I guess, make that contact. A robot doesn't quite do that yet. And I say yet because people are working on that, trying to give that soft touch aspect to it. I mentioned it's expensive, not only to the patient though, but also to the medical practice. It may have complications in the short term. Movement latency is one of those aspects that are, I guess, at the forefront of my mind. I'm sure you've tried to go on YouTube before and watch a video, and at some point it'll stop and buffer for a bit. Now imagine a robot trying to do surgery and suddenly stopping halfway. That's unacceptable. You can't really do that. Or the flip side, you don't want it to quickly speed it up. Can't do that either. Not acceptable, leads to a whole bunch of issues. You actually need a constant power supply. So you've got a human on the operating table and you've got the surgeon with them. The humans, well, you'd assume the human would not run out of energy, but a robot could lose power. What do you do then? Sensitive information. So the robot or AI algorithms or data points will be using sensitive information to make those decisions as part of what you're using the application for. How do you govern that? How do you make sure that the wrong person doesn't get access to the data? And I mean, look at the Medibank data breach in Australia at the moment. Perfect example of where that can go wrong. Legal complications and consequences. Is the robot liable if something goes wrong? I'm not going to touch that issue because that's one which I think everyone is still trying to find out what to do. But the most positive, yet still a risk, is it's still continuing to improve. So what happens today is not the end state. What happens tomorrow is not the end state. It will always be a continuum of evolution. So at what point do you begin to trust that the robot can actually help your specific use case? And I say trust because how often do you trust a machine to do what you want it to do? How often have you tried to get a candy bar out of a vending machine and it's gotten stuck in there? That's a really simple use case, but I mean, I've definitely have gotten it stuck in there. But the future of, I guess, life sciences, medical sciences, biological sciences using robotics is still very, very high. There's a lot of applications like you can see on screen, such as metahumans, neuroscience, nanotech, biotech, regenerative medicine that can also, I guess, benefit off the back of robotics, because it is about automating things as well. It's not necessarily about always recreating the human, it's about automation. That's the other side of it all. And I guess this is a lot going on in this slide. I guess what I'm trying to say is robotics by itself doesn't quite work. Robotics needs to be in tangential with artificial intelligence, because the robot needs to be autonomous. That's the ultimate end state. Fundamentally, AI plus robots is an operational technology. It's not a payroll system. It's not a HR system. It's something that is on the front line doing an actual operation at the end of the line. And cybersecurity, not one that is synonymous with the industry, but given everything that has happened in the last couple of weeks, given, I guess, the risk exposure from a defense perspective from cybersecurity, it means it needs to come up down there. And robotics aren't always designed with cybersecurity in mind. But robotics is a machine, right? It's end of the day, it's a tin. It's like C3PO. There are human factors. There's the sensitive side. There's the emotional side, empathetic side. Robots can't quite do that, and that may ultimately be the distinction between who we are as humans and robotics one day. Maybe we can feel emotions. Maybe robots can't. I think it's Wizard of Oz with Tin Man that can't feel emotions. That could be literally what robotics are. But where this is moving to is robotics are moving to become more and more autonomous. Level 5 autonomy as the self-driving car, I guess, continuum is no humans in the loop. Robotics just do it for itself. Artificial intelligence. So I guess a lot of the algorithms we have in place are narrow. They're specific to a specific use case. A robot to emulate a human, it needs to be generalized. And what I mean by that is you and I can go out and make a cake, take a shower, go plant a seed in the lawn or in the grass itself. A robot can't do that. A robot doesn't know how to switch different modes. And so that's what it means by general AI. That's still a long way to go. Operational technology, so things need to be data driven. That's where the world is going. COVID has sparked the digitization craze, using data to really empower what that next thing looks like, which we're well and truly on track for that. But the more data there are, the more issues they become. And that's why cybersecurity is back on here, because we need to design solutions with cybersecurity and hardening by design. But again, I said this before, the thing that will make or break robotics in its use cases is trust. It may solve a whole bunch of issues, but there's a number of things we need to work through with that. But it's not a negative, it's actually a positive, because we are moving in the right direction. And you look at space, and as an example, we need that. And with that, it comes to the conclusion of our presentation. Hopefully this has given you a bit of an insight in terms of what robotics looks like today and what it could look like in the future. Thank you.